most of you already know that the PSE is the power source equipment, and the PD on the other end is the power device, the PD. So you can have the end span and the mid span. The mid span, just like the nomenclature implies, it's just in the middle. So what we'll see next here is the standards that are supported. So yeah, we want to really emphasize where you may run into trouble sometimes. So this is an important slide, and this is where the D-Link products works well with the NetAlly products, especially the Link Runner G2 or the Etherscope, where using the correct testing equipment, you can make sure about the power that's going over your pins. Alternative A, that's where the power is over pins 1, 2, 3, and 6. Alternative B, where the pins are over 4, 5, 7, and 8. And that's what you look for. So on the next slide, we'll see that you'll have the PESEs and the PD. There's a big difference between a compliant product and a compatible product. So you'll see on our chart here, the switch can supply power to all the PDs, because if the PD you see on the right supports alternative A and alternative B, it could receive power from an alternative A and B switch, an alternative A switch, or alternative B switch. But on the next slide, we'll show you if your PD, if your power device is compatible, but it is not compliant, you will not receive PoE power. Very important concept there. Now, what we'll see on the next slide is just a couple of things where it just talks about how the power goes over the wires. Now, we have this information in the slide deck. So anyone who requests a slide deck, you could get the real detailed analysis of how the power goes over the wires. So we could just go through each slide very quickly. So we'll go to the next slide, and that's going to show you the pairs, whether it's 2 pairs, whether it's alternative A or alternative B. And you see this on the next slide also. It'll show you all the ports. So if we get to the BT slide here, you'll see that power goes over all 4 pairs. So there's power over 8 wires. So that's what we'll see. And we'll demonstrate that today when you see our Link Live demonstration, and you'll see what Mike has to show you.
All right, so I'm going to jump through a few of these slides right here. Let me go back to the slides. And there's one slide right here I really want to point out before I start doing some of the demonstrations. And that is, we're going to be talking about 802.3 BT. And we notice what our voltage range is. It's 41.1 to 57 volts. Now, here's the thing. We're working with voltage and current. And when we work with current, what we find is that as the resistance of our cabling goes up, the amount, our voltage for a given current draw goes down, Ohm's law. So part of the demonstrations today are going to be showing what happens when we start getting close to these voltage, the lower voltage level, and what can cause that. So Dan, NetAlly, Brandon, Michael with D-Link. So you're probably going, so what am I doing here? Well, part of what I'm doing here is I have the NetAlly equipment. D-Link sent me a switch. So my role in this is to put this stuff together and show the interoperability and show some of the different scenarios we can run into. And when we were working on the name for this presentation, it was the cost of failure. And oftentimes, we look at, how do we implement these? What are the technologies behind them? But it becomes really important to ensure that everything's going to work. And kind of from a personal standpoint, Dan brought up that land meter. Back in the early 90s, I was helping build what we called then the new Kenworth plant here in the Seattle area. It's now almost 30 years old. And as we were building that plant, one of the things I purchased back then for the company was a land meter. So I started out as a land meter user. But I had this brilliant idea well before PoE came out that we would power all of our time clocks using power through the data cabling. And I tested all of it, it appeared to work, and then we came close to opening the plant, and I found out that we just didn't have enough power going to the time clocks at the back of the plant. And there was this panic of, we've got to open this up. People have to be able to clock in and out. We don't have enough power. And in that case, I was afraid the cost of failure was going to be my job. So when we're deploying these technologies, we need to not use the S word, and that should. And that is that connection should power that. That should work. So my focus in my part of the presentation today is going to be getting rid of that S word and showing you how we can go in and validate some of these things. So what I'm going to do is it's time to get rid of the PowerPoint, and let's bring our Link Runner G2 over here. And we'll hit the power button on that. We'll wake that thing back up. And so what we've got, and I'm just using a little application here to share the screen. This is the Link Runner G2. We'll flip over to our camera here. We'll take a look at what do we have with the Link Runner G2. Well, with the Link Runner G2, let me move this other camera real quick so you can see it from the front and the back. It is an Android-based device that it's got a touch screen on it, and we're going to be using this to do some of our network testing. And up here on the top, we've got a 10, 100, 1000 Ethernet port. We've got a 100/gig SFP slot on there. So we're going to be using this to do some of the testing. The other tool that we're going to be looking at is our Etherscope NXG. Now with our Etherscope NXG, let me grab a stand for that. Although the stand fell off, I 3D print these stands, and part of it broke off, so we'll see if it holds it up okay. One of the things that's pretty slick about the Etherscope NXG is that the copper port here supports 10, 100, 1000, 2.5, 5, and 10 gigs. So as we start moving up beyond gig, we have that capability in there, and the SFP slot supports 10 gig as well. So we're going to be using these tools today to do some testing of a variety of different network connections and what we can do when it comes to validating that our PoE is working properly. Because what I don't want you to run into is a situation where you've gone in and deployed it, everything looked like it was going to work, you go to turn up those cameras, you go to turn up production equipment, and that equipment doesn't work. So there's a variety of scenarios, and I'm just going to come over here and also go to the question section. So I'll be keeping an eye on that as well. So if you have any questions, we'll do our best to answer those. So the first scenario that we're going to take a look at is making sure that our port is configured for the right class of PoE. So I'm going to come into my Link Runner G2, and I'm going to go into settings. And what we see is in here we can enable PoE. So it's going to test PoE, and for the test to pass, we need to make sure PoE needs to be present. So here I'm asking for Class 8 PoE. Now, Michael referred to 90 watts at the power source equipment at the PSE, but we take into account that there's going to be a voltage drop along the link because of the resistance in the Ethernet cabling. So what we expect when we test Class 8 PoE is that we can get 71.3 watts out there at the end. Now, one of the features that I like here with the Link Runner G2 and with the Etherscope is that they both support true power. What true power does is, for a brief moment, it actually draws that amount of current. So this gives us a way to not only validate that we're getting the correct voltage, but that we're getting the amount of current that we need. So what we're going to do is we're going to come back and we're going to plug into our Ethernet switch. So I will come over here. Let me just readjust this a little bit so you can see what I'm doing. The GoPro's a bit in the way, but I'm going to take the cable right here for my Link Runner G2. I'm going to plug it into the port on my switch. Now what we see is the moment that I plug that into the port on the switch, it begins running the test. Now this gives me some information about that connection that I have. So I can see right here, I got 54 volts. So if I expand that, what we asked for, what we requested was class 8, 71.3 watts. What we got was class 4. So what I did was this switch has 6 ports of class 4 PoE, and it has 2 ports of class 8. So I plugged it into a port that only supports class 4 by, well, I did it intentionally, but oftentimes this sort of thing happens by mistake. So by being able to draw that current using true power, we see that we got about 25 watts of power, which is what we would expect for class 4, but not what we expect for class 8. We see that our voltage was right in there. And as Michael brought up, we've got alternate A and alternate B as far as which pairs the power goes on. And this is kind of an important thing with PoE. PoE, we center tap the transformers. I don't want to get too far into the weeds, but what we do is we take and we put the power in the middle of the transformer that passes the Ethernet signal. And that puts that PoE onto both conductors of a pair. So when we're looking at that, we see here our positive pair is 3, 6, and our negative pair is 1, 2. So this gives us a way that we can go in and see what's going on across that link and what type of power, what PSE type that is. And so here, we're not getting the power we expect. So in this case, if I move over to a port that is designed to support the wattage that I need, plug that in, we'll switch back here. So now we get this nice green lightning bolt, right? So we asked for class 8, we got class 8, and right here we see that our true power voltage, this is the voltage at the time we were drawing the power, is 52.7 volts. So that gives us an idea of how much voltage are we getting at the end. Now, if we go back to that slide, we remember we needed better than 41.1. So in that case, hey, we're getting the power that we expect out of that port. So as the person that's validating that connection, you're getting rid of the S word, the should. We know that we have enough power out there at the far end. Now, not only do we know we have enough power, but I can come in here and it tells me what port I'm plugged into. So the Link Runner G2 is going to take that LLDP information or CDP information, depending on what kind of switch you're plugged into, and it's going to provide information about what port you're connected to. Now, the neat thing here is that I can come in and I can also add a comment to this. So we'll take a look at this in Link Live later, but I could add a comment and say, camera 7. Now what that's doing is that is loading it up to the cloud-based results management system that NetAlly has called Link Live. And it is now attaching camera 7 on there. So down the road, we'll go back and show it. If I search for camera 7, I will be able to see what voltage I had, what power I was able to draw, and what switch and port that's connected to. Okay. So as far as helping ensure we don't fail, that we don't embarrass ourselves, by going in and doing this validation, we're able to prove that things are working well. And especially if you're a contractor that's going in and installing these systems, we want to end finger pointing. We want to be able to have a way, well, we do, there is a way. You can document how that system is working so that when you leave it, you can show that it worked the way you wanted to. And I'm sure if Michael, Dan, Brandon have anything to pipe in on as we're going along here, please do so.
Yeah, absolutely. It's very exciting because, as Mike mentioned, using the link live, that's information you can share with your customer, and you'll have the results immediately. And what you'll see is the pins that are being used for power, and it was very helpful in helping D-Link solve some issues, some PoE issues with customers.
All right, I managed to pull the boot apart on my patch cable there, so we're going to swap to a different patch cable. All right, so now in my next example, we are plugged into port 8 on the switch. But what we want to do is we want to take a look at, will our cabling support the power that we need? So I go in and I plug in at the switch. And in fact, let's do that. Let's just come over here. Now I'm going to plug in to port 8 at the switch. And let's say that you said, hey, you know what? I'm really going to validate that everything is working okay. So I plug in at the switch and make sure that the port I'm about ready to use is going to support the class of service I need. There you go. We get this nice green lightning bolt right there. And in fact, we don't see any yellow or red dots up here by auto test. Everything worked great. We got our link. We're all set. So now I come in and I patch that connection over to my network connection, and I go out to the far end of that network connection and I plug in. Ooh, all of a sudden we get a red lightning bolt in here. So why am I getting a red lightning bolt? Well, I'm getting a red lightning bolt because I asked for class 8. Now, when I pulled that much current, that much power right there, my voltage at the far end dropped down to 39.4 volts. Well, that's below the 41.1 that I need to properly operate a piece of equipment. Now, as Michael mentioned here, we can see our PSE type. We can also see which pairs. We're providing power across all 4 pairs. We started getting up to 90 watts. That's a lot of power. In fact, while I was setting up for this demo, and I'm going to show where we draw 90 watts charging a bunch of equipment, I had some cabling that got kind of hot. So we need to be really careful when we're deploying this because we're pulling a fair amount of power. So we use 4 pairs instead of just 2 pairs. So now we're distributing that load across more pairs. But here, our voltage dropped too much. So what's going on with this cable over here that is not providing the power that we need? Well, in this case, that cable that we're connected to right there is copper cladded aluminum wire. And you'd go, okay, Mike, come on, I'm smart enough not to buy aluminum network cable. Well, the box that this cable, I bought 1,000 feet of this off of Amazon. The box that this cable came in says Cat 6 on it. And that Cat 6 cable, it says that it's TIA 568 .C compatible. But I think buried way down in there somewhere, it says don't run PoE across here. But that is easy to get confused with. There's a trade show I've worked on. This is the first year since 1995 that I haven't worked on that trade show. And we had a situation where some devices were not working on PoE. And it turned out that the person that bought the cabling for the trade show had bought 2 pallet loads of copper cladded aluminum wire because it was cheaper. It's about 1/3 the price or less than pure copper. So we need to be careful to ensure that the cabling we're using will support that. Now, what I want to show you is I've talked about true power and how using true power allows us to draw that current. So if I come in and I'm going to run this same test, but this time I'm going to go into my settings and I'm going to disable true power. I'm going to come back here and we're going to rerun this test. Well, it's having a little hard time linking on that CCA right there. But what I wanted to show you in here is we passed our PoE test. I didn't move any cables. You can go back and rewind this later and take a look. I did not move any cables. This is the same connection, but we passed. We show we got 53.9 volts. Why? Because we never drew the power. If all we're doing is taking and doing a measurement where we're measuring the amount, the voltage that's coming through with no current draw, that CCA passes that voltage just fine. It's not till we add that current draw with the true power that we really begin to see that the cabling is not going to support that. Okay. And I've got some other examples. We're going to look at Link Live here in just a minute, but where we go in and we're going to take a look at thin patch cords and the effect that those have on there as well. Okay. Now, on this next one, what I'm going to do is I'm going to change my current draw. I'm going to change what I'm looking for power. We're going to say we're looking for class 4 in this case. And we're going to turn our true, not LLDP, we're going to turn our true power back on. We're going to come back in here and I'm going to unplug this. So now, in this case, I'm going to plug into a port, and that port is supposed to be all set up and ready for me to go. And I can see that I'm getting class 4 PoE out of this, just like I'm supposed to. But now I see that I've got some problems. So what's the problem? Well, I got PoE. I was able to establish a gig link. I can see that there's multiple VLANs on here. I can see that I'm connected to port 2 of the switch. I got my DHCP address, DNS. I got to my default gateway, although it didn't respond. But right here, one of the things I'm able to do is put in test targets, unlimited number of test targets. And these test targets are devices I need to make sure I can establish a connection to. So I said, can I get to Google? Can I get out to my NAS drive on port 445 for file sharing? But let's say you're installing a PoE device like a camera. Well, what good is the camera if it can't get to the video server, the device that's pulling all that video in? So by adding these test targets, not only are we able to ensure that we're getting the PoE that we expect, but that we can get to the resources we need to get to. In this particular case, we are on the wrong VLAN. So I want to be on the native VLAN here, on VLAN 1. Instead, I'm on VLAN 12. Now I know I'm on VLAN 12 because, well, that's the IP address I got. So it's critical that not only for ensuring that we don't fail, that we can get the power we need, but we need to make sure that we get the connection that we need to get to the resources that are required to make things run properly. So getting an IP address, being able to put those test targets in. Now, when we move up to something like the Etherscope NXG, we can do network discovery, we can do path analysis, a lot of other things in there with that as well. Okay. So let's take a look at one other one here.
Yeah,
and that is, yeah.
That's why I want to reemphasize why it's very important to have the tool, because many times IT professionals try to use their own laptop or maybe some free tools that they download to analyze. They won't have the VLAN tools that NetAlly offers, and that's something that you really need to consider.
Well, and that's exactly it. Now it's and that, I know, using free tools, I'm just looking for a gizmo that I planned on using here, and I have managed to put it down and I found it. So, we've been seeing that when we plug in here, that we're getting our power on, we're doing alternate A. So in this case, what I just want to show you, sometimes you really have to dig some old stuff out. And, I sometimes wonder, am I keeping too much junk around the lab here? But every once in a while, there's a reason for it. And so I've got this is a 3-COM IntelliJack. and or network jack. And so what I'm going to do is I'm going to power this up using one of the PoE switch. In fact, in this case, I am using the DGS 151028 XMP to power that. We're going to come over here. So that jack is powered up, the little light's on. So what I'm going to do is I'm going to plug my link runner into that, and it passes power through port 1. Well, that's pretty nifty. But what we find when that power passes through port 1 is that we move from alternate A to alternate B. That does a switching of the pairs. So in this case, if I had a device like this, and we see that there are PoE powered switches out there that provide PoE to 1 or 2 ports. Well, if they do something like this, it could be that you put that in line with a previously PoE powered device. And just like Michael brought up with those cameras before, if you have a device that is not compliant with alternate B in this case, that device wouldn't work when you plugged it into this. So knowing which pairs the power is coming on becomes really critical. So being able to go in and measure that. And we did a true power measurement on this, and we see that even passing through this device where it is being powered by PoE and it's forwarding PoE, yeah, we're still getting a pretty good voltage coming out of that.
So out in the field, an example, a true life D-Link example, is where we used an unmanaged switch. And with an unmanaged switch, there's no way to really check whether it's going to be mode A or mode B. And if you plug
Right.
in a compatible but not compliant device, it wouldn't power on at all. And it just turned out that the device was mode B, where it should be mode A and B in order to be compliant.
So what I'm going to do is we're going to grab the Link Runner G2 and move that out of the way right now. And we're going to come back here, and I am going to, let's see. I'm going to come in here. This is Link Live. So as I've been running these tests, what's been happening is those test results have been uploaded here to Link Live. And so I just cracked 4,000 test results that I've got here at Link Live. And let me close that. One of the things that I like with Link Live is not only are we able to upload all this information, so I'm able to see all of that info that we've been uploading, but I can come in and organize this in folders. So what I've done is I've created a folder out there, and I created what's called a job comment. So every test result that I run ends up getting uploaded to this folder. So I'm going to click on that folder, and it's going to make it a filter. So now we're going to filter down on just those test results that we care about. And so I had put camera 7 in there. Right there, there's camera 7. So if I came up to my search up here, and I said camera, and I said 7, and I hit enter, boom, there is the test result for camera 7. So out of 4,000 test results, it found that test result. So now I can come in here and I can see at the time I installed that camera, what kind of power was I getting at the camera? What type of network connection was I getting? DNS information. I can see all of that. And so I can start seeing that information that's critical to being able to troubleshoot that camera down the road. Now, some other things that I've put in here is, there's the test where we had, the wrong VLAN. So I can see that wrong VLAN information. I can put these comments in there. So some things that have come out of this testing. I'm going to type in thin. So what I did was I patched together a bunch of thin patch cords I had. And I said, what happens if we use 100 feet of thin Ethernet cable? This is 28 gauge cable. Well, what we find is that our loaded voltage drops down to 40.2 41.7 volts. It's below the 41.1 volts that we need. So I can't get 100 meters of distance out of my connection if I'm using thin patch cords, because we find that at 100 feet, our voltage drops below the minimum voltage for class 8. Then I moved into 87. So I tested all these different lengths. Now, the one that I thought was really interesting is I got down to 13 feet. Okay. Now, at 13 feet, I was at 51.5 voltages, or voltages, 51.5 volts. Now, that's pretty good. I mean, I only dropped, what, 2.3 volts. But just to compare, here is 116 feet of 23 gauge Cat 6A, 51.4. That is almost 10 times the length of cable for the same voltage drop. So the thing I wanted to really illustrate here is that when we go in and we're putting this cable in, if we're using thin Ethernet patch cords, that derates our link. So if we want to reduce that opportunity to fail, we need to be able to test that completed channel to ensure that we haven't added things in like thin patch cords that are going to cause that link to drop more voltage than we expect. So, being able to go in, test that important thing.
So Mike, am I correct in the assumption it's going to cost money because the solution is to replace the cable with a
Yes.
viable cable? There you
Yep.
go.
So when it comes to the cost of failure, I think back on, and anytime we're deploying things, I was doing some work with a prison, and I wasn't a resident there, by the way, but in that case, they were talking about what it costs to put an access point in, because they have to core drill through these concrete walls. Everything has to be in rigid conduit. It has to be, well protected. And if you get the access point location wrong, it costs a lot of money to fix that. The same is true here. If we don't do everything right before we go in and deploy it, and we're not able to measure it, I'm a huge measurement person. I could bring up, I've got some oscilloscope traces that I did of power over Ethernet, just because that's the kind of thing I like to do. But we could see PoE starting and all the pulses and everything. We need to be able to measure it, because we can't troubleshoot anything we can't measure. And we can ensure success by making sure we measure first. Okay. So in here, we can take a look at that. Another thing I want to show you real quick is here's the interface on the D-Link. And we're going to come in here, and there's some pretty cool stuff. One thing I like about this interface is if I type in PoE, it will show me all of the menu items that have PoE in the name. So I don't have to dig through. I mean, how many times have we dug through menus trying to find, which menu is that under? But the nice thing here is I can come in, take a look at the PoE system, see how much power I'm delivering, see what my PoE status is. So in this case, how much PoE is being drawn from each one of these ports. I can go into my PoE configuration, and I can configure these ports so that we can go in and limit the amount of power we're delivering to a device. I got to tell you, one of the coolest things that I think that they put in here that is, let's say that I've got a PoE camera, or I've got Raspberry Pis that I've put PoE hats on so I can drive them via PoE. But what happens when that device hangs up? Well, I got to find out the device is hung up. Then I got to go power it off and power it on. So what we find in these switches is that we can come in and put in the IP address of the device that's connected to a particular port. And we can say, PoE alive state enabled. We can put in the IP address. We can put in the poll interval to retry. What will happen is this will ping that device on that interval. And if that device doesn't respond to the ping for the number of retry counts, it kills power to that port and brings it back up. Just make sure if you set this up, you got the right port with the right IP address. Otherwise, you're going to have the switch shutting the wrong port up, off and on, and driving somebody else nuts. But what this does is this just gives us a way that we can wait, and we can select what that action is going to be to reset that. So we'll actually reset the device. So what we're going to do is we're going to come over here, and let me move my camera before we do. I bought, for this webinar, I bought a PoE splitter. Now what this PoE splitter does is it takes the PoE and it splits it out to 12 volts. So it splits out a gigabit Ethernet connection, but it also splits it out to 12 volts, and it will run up to 4.5 amps of 12 volts. So the neat thing with these PoE splitters is that we can take and power devices that were never intended to be PoE. We can do lights, I've got a USB adapter plugged in there. I can charge USB devices. But if I have a location where I need to be able to power some switches, some routers, and I don't want to run power to that, I could put a PoE splitter out there and split the power out. So what we're going to do is I'm going to come over here, and when I was setting up for this, I was using some other cable that ended up getting really hot. So in this case, I'm using some of my 23 gauge PoE cable. We're going to plug that in. Now, what's on the other end of this PoE splitter? It's a pretty expensive little load bank. I've got the PoE splitter charging a whole pile of Link Runner G2s and air checks. But what this allows me to do is if I come in and look at my PoE system right here, we see that we're now delivering 81 watts. And if I go to PoE status, we see that out of port 7, we are delivering 81 watts of power. I guess I could try and plug one more in and see if we can crank that clear up to 90. But what we're seeing is that this switch is delivering almost that full 90 watts of power out there. I got to be a little careful because the wires I have charging those start getting a little warm. They were never really intended to run that much power. But in this case, hey, we're delivering that full power out there. It's a class 4 device. All right, so I'm going to go ahead and let's see. Let me see if it's getting warm. Yeah, it is. So we're going to go ahead and disconnect the power on that. That was more just as a little demo. Those splitter cables were really meant to run video cameras, not charge a whole bunch of devices. So Dan, Michael, are there any questions that we want to address while we're going through here?
Hey, Mike, it's Dan. I think we've largely answered these. One of the questions that did come up was, is the test that you're showing on Link Runner G2 available in the Etherscope? And of course, the answer is yes.
Yes. Yeah, in fact, here, I'm going to stop sharing my screen. I see somebody asked if they could get the camera image bigger. I'm going to stop showing the screen for just a second, so we've got a little bit bigger video on there. And let me grab the Etherscope NXG right here.
And while you're doing that, another question came in. Some people are looking at those wonderful 3D printed stands, wondering where you got those. Just in case anybody has a NetAlly tool, you can go to Thingiverse, and I assume that if you're in the 3D printing community, you probably know all about Thingiverse. Just do a search on NetAlly, and you'll find all the various 3D print files located on Thingiverse for printing your own stands.
Yeah, I gotta say, Bob Vixie over there at NetAlly, he and I were talking, and he showed me some of the things that he's developed with and put out there on Thingiverse, and then he put these stands together, and I've got them for the Link Sprinter, the test accessory, all the different tools out there.
Bob happens to be listening in on the webinar right now. So thank you, Bob, for all your 3D design work.
All right, so I'll tell you what, let's do this. I'm going to connect up. Let's connect in. We're at 11.139. We're going to VNC into that thing. Let's bring that up. And we're going to share. And let's see, we're going to say, how about that? There's our VNC viewer. So this is the Etherscope NXG. And so just like with the Link Runner G2, it is Android powered, and these are all the different tools that we have available on there. So when we come into auto test, I'm going to go in here. We're going to take a look at that. We see something failed auto test. We could come down. Oh, getting to NAS2. I need to call Uta about that and see if we can get that NAS turned back on. But we see that with the Etherscope NXG, we're doing the same thing. We're drawing power there. We can draw up to class 8 power with this. One of the things that is a real nice advantage of the Etherscope when it comes to testing this is not only can I run an auto test, but I can create a profile that has multiple auto tests. So if I come in here to my configuration, I've got this whole library of auto tests. And so for instance, let's come down here, let's grab VLAN 14. So in ensuring that everything is going to work properly, let's say that I want to make sure that both the native VLAN and VLAN 14 work on here. If I hit start, what it's going to do is, well, something has occurred where my screen is not updating. Let me close that real quick. Let me go back in there again. There we go. We will reshare that. There we go. So we see that we're testing no VLAN. So we're testing our native VLAN. We're going to come back. And as soon as that gets done running, well, this is, I don't know if this is a combination of go to webinar or go to meeting, but it has decided to stop updating my screen properly. We'll go in there one more time.
But the Etherscope features that same load test capability, and I guess that's one of the key points that you're making here is that there are a lot of testers available out there in the market. PoE tester, test PoE voltage. You can probably get them for $20, $30, and using them, you may be led in the wrong direction that a Link is delivering the PoE you want, but it's really not.
Exactly. Yep. And so being able to put that load on there. So we find that with the Link Runner G2, with the Link Runner 10G, and with the Etherscope NXG, we can do that on all those. All right.
I'll just mention to our audience, if there are any further questions, please feel free to ask those in the questions tab. We're getting towards the last few minutes of our webinar here. Mike, any last points, either from Mike Panaki or Mike Friends?
Great job, Mike. Any questions, feel free to reach out to Brandon. If you guys need an actual training on the D-Link product line or the D-Link switch, we will be glad to help. And Brandon, do you have anything else to add?
No, that's about it. Yeah, anything for we have a wide variety of PoE devices, as we covered. That the one today is PoE Plus. We have PoE Plus and then standard PoE. Covers all your 802.11 needs, right? ATA, FAB. But yeah, anything we could do to help you guys out, trainings or technical support, we're glad to help.
Thank you. Great job, Mike Panaki.
I guess the last thing here, oh, sorry for interrupting. Last thing here is to announce our winners. So for the Link Sprinters, I'll announce those and then hand it over to Brandon to talk about the winners for the D-Link products. So Jennifer C. at PSD Schools, you're a lucky winner of a Link Sprinter, and also George R. at Skagit Foods Co-op. So congratulations to our Link Sprinter winners. Brandon, over to you.
Thank you, Dan. For our giveaways here at D-Link, we have Peter P. At Walmart. He'll be getting the DGS 1100 05V2. And then we got Cody E. at UCCS. He'll be getting the DGS 108GL, and I'll reach out to you guys direct on email.
Fantastic. Well, Mike and Mike, thank you very much. Mike Panaki, really appreciate the lab setup that you've done for this. Really helps illustrate some of those key problems of power over Ethernet and what we need to look out for.
Oh, you're welcome. You know, I love getting out here building this stuff, so.
Right on. All right, I guess that's it. We'll wrap up the webinar for today. Thank you to all of our presenters, and thank you folks for joining us.
Thank you, Dan.
Signing off. Cheers.
Thank you so much. Bye-bye.
Take care.